Afternoon, good evening to anyone virtual attending or watching recording. My name is Mark Buffington. I'm a consulting engineer here at Jamf, and it is my pleasure to welcome our friends at AWS talking about EC2 Mac. Some fun projects, good use cases as well. And today the session is a deep dive into managing and securing Apple environments with AWS and Jamf. And everyone, please welcome Dave Siderer and Mayank Gupta, please. Good morning.
Thanks, Mark. Thank you, Mark, and thank you, everyone. Especially thank you for joining us at JNUC 2023, taking a look into a deep dive into managing and securing Apple environments with AWS and Jamf. I am Dave Siderer. I'll be joined by Mayank in a bit for a dive further into Jamf Trust. Earlier in this for the conference, we actually did a bit of a first look at EC2 Mac instances themselves. This was the picture that we'd actually put up, because this is an EC2 Mac instance. The large part of it probably very recognizable. The Mac Mini is actually at the center part of it, but this is basically the assembly that sits in an AWS data center when we do the things that we're going to be clicking in just a moment. The piece that sits on the green card there, that's what's called an AWS Nitro card, and that is actually bringing storage and networking over Thunderbolt to this Mac Mini. Along with that, it's managing physical security and ensuring that things like firmware updates are happening with mechanical automation as well. And of course, EC2 Mac instances with Jamf. Last year, we had introduced agent-based enrollment, a full workflow for EC2 Mac instances and into Jamf Pro. We later had a workflow around augmented, basically guided MDM enrollment. We do have coming out very, very shortly and available for private preview right now. There'll be a link at the end, full automation around mobile device management, MDM user-initiated enrollment for EC2 Mac instances. We're going to be taking a look at the console, actually how to basically how to grab an EC2 Mac from the server and make use of that. So as far as our folks in the room, show of hands, folks that are familiar with the AWS console at all. All right, a few folks, and that's all right. We are going to be looking at that today, but one of the focuses that I really want to take is sort of what everything is and how it's going. So we may be moving a little bit slowly as that goes. So if that's all right, I think we're going to take a look at how it is to grab an EC2 Mac instance. The first thing we're going to need to do, this bit of a spoiler, is click EC2 within the AWS console. This is where we're going to be able to start our instances, and you'll see there is an orange button there that says Launch Instances. It is going to be something we're going to be using, but not quite yet. If you're familiar at all with starting other virtual machines, EC2 instances, a lot of the time it's sort of click that button. Since EC2 Mac instances, we saw that physical host that we had in the rack. This is something that is considered a dedicated host. So in order to do that, there's mainly one step that we're going to have to take before we are able to launch our instance. So the first thing we're going to be doing is going to dedicated hosts in the sidebar and saying, it's time for us to have a Mac Mini to launch things onto. Obviously, I have a few in my console here. I'm going to click Allocate Dedicated Hosts and give this a name. We have now, as of Tuesday, 3 different types of EC2 Mac instances: Mac 1, Mac 2, and Mac 2 M2 Pro. These 3 are the x86 Mac Mini, the M1 Mac Mini, and the M2 Pro Mac Mini. So that with 32 gigabytes, 16 gigabytes, and 32 of RAM, respectively. So we do have these offerings. As you go into the console itself and choose the instance type, it will only give you one option as you go into or rather, when you choose the instance family, it gives you one option on instance type. Availability zone, this is something we do have documented as to which instance types are available in which availability zones. And when you do pick one and there's no hardware that is available for you at that point, it will actually let you know where's a good spot to go looking again. I'm going to point out two other things here. One thing I'm a big fan of is auto placement. When we're all launching an instance, a lot of the time we have you either have to say which host you're going to launch it onto, or or just have auto placement on. So we don't actually have to designate. We just have to say we have a Mac Mini and it's time to launch some software onto it. So that was what it took to allocate the host itself. Now that we have a host, we need to start an instance onto it. So a way to think about this is a host is the physical Mac Mini, and this is basically like the disk that you're plugging into. We're going to launch this with an Amazon Machine Image, or an AMI. I've mentioned the word imaging a few times, and I know that we all have some reaction to that word in one way or another, with fondness or not, or both. And that's one of the things I do like to point out, is that a lot of that here is best of both worlds. So we are able to not only start from an Amazon vended image, we can take our own snapshots of this and actually create derivative snapshots with pre-configured information. This one field down here, it is important. If we're using a Mac 1 host, it is pre-selected as x86. And the dropdown, it is important to flip this to Mac-ARM, because this will actually change that to a compatible instance type that automatically on the bottom there, and that's for Apple Silicon. Pointing out the SSH key pair here too. This is for an EC2 Mac instance. Normally you'd have a username and password. That's not set. We have a username and we have an SSH key to ensure that your connection is going to be a bit secured differently, since this is entirely remote. So here it's possible to create your own SSH key pair. I happen to have one on hand, so I can actually just pick that from the drop-down menu. Security groups and network settings. I don't want to dive into the entire complexity of networking, because we definitely have some folks who can take some wonderful time on that. But specifically, I did want to point out the security group itself. What we're going to be showing today, we're going to be using SSH to connect to this instance. So we just need port 22 open, and we'll actually show a little bit. We're only going to use port 22. I have a security group that has the same privileges called default, so I just picked that one for this particular demo. Storage, I do want to point out, there are different classes of storage. If your workflow is one that's more focused on I/O, you may want to use something faster, test out different classes. There's absolutely quite a bit of options on Elastic Block Storage, or EBS. And I did click the Advanced Details triangle because, we're all advanced here. And also there is a required field. Before we get to the required one, a few things to point out. This is an instance profile. This is if you wanted to grant this instance the ability to get to another thing or access another thing in AWS. This is where you can kind of designate that. We have in our workflow the ability to grab a password, and we don't want that to be accessible to anything else, and that's where that goes. The other thing to point out, tenancy. This is an absolute requirement to launch your EC2 Mac instance. This must be set to dedicated host. And I'd mentioned auto placement earlier. Since that's on right now, I don't need to touch anything else there. That was actually the last step that I needed to perform. So right now I have a plain vanilla EC2 Mac instance that's launching. It probably took about 6 to 20 minutes to launch. And once that's up, we have there is you can see a status check 2 of 2. We can connect to that instance. So to start with, we're going to SSH in, and I do have that the particular key. In connect to SSH, there's a nice shortcut here. I'm going to grab that shortcut and I'm going to add a little something extra, because I want to connect to the GUI. I'm going to SSH, and I'm also going to tunnel the port that I need for GUI connection over SSH. So taking that command, just as it was copied off of that page. It does mention, it gives us the path to the PEM file itself for the key. And I'm going to add a -L, which is for the port redirect, and 5900 at the beginning. I'll be redirecting port 5900 to my local host of 5900. So this is a method of tunneling the actual screen sharing protocol over SSH to allow something either without VPN or a very easy way to ensure that only certain ports are open for you. So this is my first time connecting to this instance. I'm going to say yes to the new fingerprint. And from there, there are just a few small things. We do need to set a password in order to access the GUI. This is something that macOS has as a requirement. And we need to kickstart the screen sharing service as well. So I just have a few commands that are, we do have this in our AWS EC2 Mac documentation as well. So I can promise you what's pasted in here is not secret. And this is going to set our password, and this is going to open that door to screen sharing. So the password, this is always, I'd say, the anticlimactic part. It's the pieces of text, and then the pieces of text, I'm going to open screen sharing from here and connect to localhost, which since I'm sharing that port over 5900, I'm connecting to my own port 5900. If you do have screen sharing on your particular Mac, you may need to deactivate it for the time being if you're using this method. But if there are also other ports that you can use to redirect that to. With that said, I've got the password that I'd set earlier. I think it was something very, very secret, 5 very secret letters. And that is, I'm going to log in here to a very, very familiar screen. And we have our login window. So as an EC2 Mac instance, this is a Mac in the cloud. This is booted from the image, the Amazon machine image that we'd asked it to be. And this happened to be one of the more recent options. This is Ventura. We can go back to previous versions of the operating system with that same mechanism, being able to just say, I want this image, and this will ensure that we have the correct firmware to start. And just pointing out here, this was a Mac 2 instance, so we have the M1 hardware at the back of this here. And diving into, now that we have our instance, to show a bit of what enrollment looks like. This is a script, again, something that I can make available to anyone to take a look at and use. This will allow you to get your instance into Jamf MDM enrollment. So it's 9 o'clock. It's 9 o'clock on our Thursday. So words are to be stumbled every once in a while. And our enrollment actually happens behind the scenes. So what we're watching right now is happening, but the user has not connected yet. This is actually a recording of the screen after boot and prior to connection. So this is performing it's building the profile itself, the enrollment profile. This is taking care of the UI as needed to ensure that this instance is successfully enrolled. It is using saved credentials that have been securely saved in, it can be AWS Secrets Manager or Parameter Store. All of this leads to, at the end, a user-initiated enrolled EC2 instance, and one that you're able to deploy out sort of in this state, so that when your image reaches its host, it performs its enrollment and gets all of the profiles that it'll need, along with self-service and any policies, and as that goes. So this is that's a bit of enrollment and spinning up an EC2 Mac instance. And now to dive into a bit more towards Jamf Trust and Amazon Verified Access. This is Mayank.
Thank you, Dave, and thank you, everyone, for joining us for this session. The last couple of days has been great for me, honestly, because I'm still working remotely. I'm working from home and don't get to see and meet so many people in person anymore. So thank you, Jamf, for arranging JNUC and inviting us here for JNUC. And speaking of working remotely, there's one thing that I have to do every day, which is connect to a VPN. And honestly, I don't like it because, to be honest, I always forget to connect to a VPN, right? But that is why I'm here today. I'm going to be talking to you about a new networking service that we launched last year at reInvent, which went GA earlier this year. And it's built on zero trust principles, and it lets you, our customers, connect to their corporate applications without a need of a VPN. Isn't that great? It sounds exciting. So, hello everyone. Hello everyone. My name is Mayank, and I am a technical account manager with AWS. And I'm here to talk to you about AWS Verified Access, how that works with Jamf Trust, how it integrates with Jamf. And once you have enrolled your devices with Jamf, how can we use that enrolled device with Jamf to gain access to that corporate application without a need of a VPN. So within the next 15 minutes or so, I'll be talking to you about giving you explanation about the challenges that we generally face with traditional VPN, introduce you to verified access, tell you about its benefits, show you how easy and simple it is to actually set up, integrate our applications and access them over the internet without a VPN. Talk to you about some of our integration that we've done with Jamf and other partners, and then run a quick demo and wrap it up after that. Right, so talking about challenges, historically speaking, when we all used to be in our offices, accessing your corporate applications was pretty easy and simple. You're on the corporate network, you can access it. But as we started moving and working remotely, the corporates and the enterprises had to find a way to make those applications available to remote users in a secure manner. Now, in order to do that, enterprises spend a lot of time and efforts in setting up VPN solutions. And often these VPN solutions require multiple teams to work and coordinate together, and they often overlap each other's efforts. So, for example, network administrators, they have to manage network level policies to make sure the users have access to VPN. Application owners, developers, they have to manage application level policies to make sure the right user have access to the right application based on their roles, based on their identity, based on which department they are in from. And then IT administrators, they have to manage the device level policies to make sure the device that has been used by the user to connect to the corporate application is actually secured, is managed, is at the right level to make sure it's not vulnerable to anything. And then if you have to make any changes to any of these policies, it can take days, it can take weeks, it can possibly take months to get approved and go through the change. And for example, for me, it's not a great experience for an end user, right? So I always keep forgetting connecting a VPN. When it's also an added task for the end user to connect to a VPN, it's possibly they have to connect it multiple times in a day. So we at AWS, we started thinking, how can we improve and simplify the whole VPN connectivity experience for our customers? So we wanted it to make something which was secure, yet it was simple to manage, to use. We wanted it to be easy for the administrators to maintain after they have onboarded, they have set it up, and we wanted to provide them with great visibility into the logs so that it can help them debug and everything. And finally, we wanted to make it VPN-less. We wanted to enhance end users' experience and remove that one added step of connecting to a VPN every day. But then here's the challenge, right? If you're going to remove the VPN, how are we going to have the same level of trust between the end user, a remote user, and the corporate application? How do we know whoever is trying to access the application over the internet is actually who they say they are? So we reached out to our customers, we spoke with our customers, and we asked them, what did they look for when they were building or they were establishing that trustworthiness between their remote user and their corporate application. And all of our customers was talking about zero trust. And now zero trust can mean a whole lot of different things to a whole lot of different people. But for most of our customers, it came down to two things: identity and device. That is what led us to develop AWS Verified Access. It is basically leveraging identity and device postures, getting signals from identity and device postures and device to establish that trustworthiness between the remote user and the application. And that is what then has been used to provide a VPN-less experience to the end user to access the corporate application. So let's quickly have a look at some of the major main components of verified access. There are essentially three main components. The first is our fine-grained and dynamic policies and authorization. So basically what we're saying is you can define an identity and device level policies within AWS Verified Access at one single place, at a central location. You don't have to maintain at multiple places, multiple teams don't have to really coordinate anymore. It's just one team can manage it all from one place. And to make it easy and simple, AWS developed its own policy definition language called CEDAR. And that language basically enables our customers to define that combination of policies using identity and device in one place. And we also, all of our authentication requests that's coming in for any application is verified in real time, and each of the requests has been evaluated. Second is the improved observability. So we have provided a rich visibility into logs to our customers. So all our requests coming in, be it a deny request or be it a permit request, they are all logged in a central location, and which is a great benefit for our customers because it helps them with meeting their compliance, it helps them with their audit purposes, and because it's centrally logged, it provides them a great visibility and chance to respond quicker to any security incident. And finally, our trust providers. So verified access is built on an open ecosystem. What that means is our customers have spent a lot of time and efforts incorporating with their existing third-party identity providers or trust providers, right? So we don't want them to rework on that. It's an open ecosystem. You can onboard your applications onto verified access using your existing providers. You can bring on your existing identity providers and your device providers. So let's have a look at some of the benefits. So we think that we have enhanced the security posture with verified access because traditionally in a VPN solution, a user would make a request and that request has been evaluated once, and then the user has been granted access to the application or to the network. Now that is, in our opinion, a risk to the business because when a user gets access to an internal server, they can actually hop between the network and gain access to other important and sensitive data. But with verified access, all the requests that are coming in are being evaluated in a real time. And since all of these are done for each request, even if for the same application, even if it's the same user, the request will be re-evaluated. And because of that, it's really difficult for any bad actor to enter the network and then hop between the applications, gaining access to any other sensitive data that they're not intended to. And then since all the logs are stored in a central place, it provides great visibility to the administrators, quicker response time to any incident management. Second, obviously, we improved the end user experience. We have eliminated the VPN client. We have eliminated the need of connecting to a VPN. So users can actually access their applications from anywhere, from a cafe, from right here in this room, from anywhere. And third, we have simplified the operations. We have removed the overhead from the IT departments. We have centralized everything. You don't have to define your policies anymore in 3 or 4 different places. You just have to define it one place, the verified access console, and that's all that you need. And secondly, like I said, it's an open ecosystem. You don't have to bring in the different, you don't have to rework on your policies with your third-party providers, identity or device providers. You just on board with your existing ecosystem. So with that, let's talk about some of our integration with our partners. So we have worked really closely with different partners, and while we were working verified access, we worked really closely with Jamf to understand exactly when a device is enrolled with Jamf, when a device has Jamf Trust installed, what device signals, what claims are being generated and can be used and can be sent over to verified access, which we can then use to define the correct level of trustworthiness, to define if the user is trustworthy, if the connection itself is trustworthy, if the device itself is in the right posture to be granted an access. So similarly, we have worked with different of our partners as well, but right now, when it comes to identity provider, we support IAM, Identity Center, which is AWS SSO formerly, and any OpenID Connect provider can be integrated as a trust provider to AWS Verified Access. And on the device side, we currently support CrowdStrike and Jamf. And all our logs are also stored in a standard format, so you can actually bring on your existing SIEM providers and you don't have to reintegrate anything, you just continue using them. So let's have a look at how simple it is or easy or quick it is to set up your application or onboard applications to verified access. It's essentially 3 steps. First, you connect your trust providers, your identity and device trust providers. You onboard your application. You create an endpoint for your application. And third, you define your access policies. You define what information you need to check and define to grant or deny an access. And that's it. And once you have defined your policies, your users can access it from anywhere. So let's have a look at an example architecture of how verified access will work. And this is exactly what is being used in the demo in the following slides as well. So as you can see, I have two applications deployed in my account right now in my VPC, an HR application and a sales application. And I'm using Identity Center as my identity provider and Jamf as my trust provider, device trust provider. I have my domain and I have a domain certificate in my ACM already. It's AWS certified certificate manager, sorry. And then I want that my sales user should only be able to access my sales application. My HR user should only be able to access my HR application, whereas the admin user should be able to access both of my application. So how would we do that? The first thing would be to integrate our trust providers. So I'll be integrating my identity coming from identity users from the Identity Center, and I'll then be integrating Jamf. So a device which is enrolled with Jamf would already have Jamf Trust installed on it. And so when I integrate my Jamf trust provider with my AVA instance, we would be able to get the claims back from that device on the verified access instance and then evaluate them. Second, I would create a verified access instance. And within that instance, I'll be creating 2 groups, one for each of the application. And within that groups, I'll be creating an endpoint for each of the application as well. Now that endpoint is what we will be using to make an entry in our Route 53 as a CNAME entry so that the users over the internet can access using that CNAME. And once we have the endpoint, we'll define a group level policy. You can have an endpoint level policy as well, but for the purpose of this demo, I'm defining at the group level. But during the demo, I'll show you exactly how you can do it at the endpoint level as well. And once you have the endpoint, if you made the entries in your Route 53, your users will be able to access the application. So if the sales user will be able to only access sales, and the HR will only be able to access HR. And when I go into demo, I'll be showing you the example CEDAR policy that I used, which actually makes sure that the user is only able to access the application they are intended to access. And you can see the C names on the top. That's the entries that I'll be making in the Route 53. Okay, so moving on to the demo. It's basically a slide of my identity center. You can see I've created groups and I've created users, and the users and groups are in the right groups and users, so that the HR user is only in the part of the HR group and the sales is only part of the sales group. That's important because we want to make sure that the user is in the right group to access the right application. Going into the verified access, the first thing that we do is when you go to the VPC dashboard, you will be able to see on the left side, if you scroll down, the VPC verified access section. And the first thing that we have to do is we have to go and create our trust providers. So the first trust provider we're going to do is create an identity trust provider. So we'll provide the basic details as name and description. The important bits are the trust provider information. So the policy reference name is really important because that is what we will be referencing back in our CEDAR policy, which basically is going to be the place where we reference back to make sure the user is coming from the right identity provider. And you can select IAM Identity Center, or if you're using OpenID, you can click on OpenID. And when you do that, you will be able to provide more information about your OpenID Connect. And similarly, we'll create a trust provider for your device as well. So again, policy reference name is utterly important because you'll be referencing that back in the CEDAR. And when you click on device trust provider, you'll be given two options, Jamf and CrowdStrike. So you'll click on Jamf, and at that point, you'll be prompted to provide your tenant ID. This tenant ID is what is going to be connecting to your Jamf instance and then getting claims back from that. So once you have created your access trust providers, you then have to go and create your verified access instance. And you click on create verified access instance, and you'll be given a screen where you'll provide basic details, and then you have to select one of the trust providers. It's important to tell you that we can only select one trust provider at this screen. You don't have an option to select both the trust providers. So you can choose anyone that you like, but once you have created your instance, you can actually click on the instance, and then you can click on verified access trust providers, and then you have an option to attach your second trust provider. Now, you don't have to have both the trust providers, identity and device, but you do need, the minimum that you need is an identity trust provider, so you can just go ahead with the identity trust provider. So you can, and once you click on that, you get a drop down to select your second trust provider, and then you can attach your second trust provider. Once you have done that, the next the next step is to create your groups so that you can actually onboard your applications on those groups. So just going to create a group, and when you're creating the group, the important bits are select the correct verified access instance. And now you can see the CEDAR policy that I've defined. Over there, I'm making reference to the IDC policy, the policy reference name from my identity trust provider that I said, and I'm checking that if the user's group is the correct group. So if the user is coming from the sales group, it has to match the sales group that we created in the identity center. And similarly, I'm also referencing back to the Jamf policy, the Jamf's device trust policy that I had created. And over there, I'm checking the device posture. I'm making sure that the device posture is returned by Jamf portal, the Jamf Pro instance, and it's actually saying it's either secure or low or medium. If it's anything other than that, the access should not be granted. The user should be denied access. So similarly, we'll be creating the same group and the policy for my other application also. And once I've done that, the last step is to create your endpoints for your application so that you can make an entry in your Route 53 and then give access to a user. So to create that, we'll click on Create Endpoint. And again, the important bits over here is your application domain. So it could be myapp.example.com or example.com, amazon.com. And you have to have a domain certificate because we do encrypt the data between your endpoint and the entry point and the front door as well. So you need to have a certificate in your ACM. If you don't have, you can create a certificate for your domain in the ACM. That's AWS Certificate Manager. And then on the endpoint details, provide details about your applications. Obviously, it's deployed in your VPC, so you'll select VPC. You'll select the right security groups for your VPC on your application. And then you have to provide an endpoint prefix. So, for example, hr.example.com. This is my endpoint that I want users to use, so I'll be going to HR. And at the endpoint type, you could have two options, either network interface or a load balancer. We only support HTTP and HTTPS protocols right now. So I'm going to go with load balancer, and I'm going to select and provide a port for my load balancer and select the ARN for my load balancer and select the appropriate subnets. And I have left my policy section over here blank because I'm inheriting the policy which is coming from the group level. But if you want to have further fine-grained access to your application endpoint, you can actually provide a more finer-grained policy over here in this section. So this is an example. For example, you have multiple applications within your HR group, and this endpoint is for one of those applications, and you want to further fine-grain access to that particular endpoint. You can actually define furthermore policies over here. And similarly, we'll create for the other application also, and we'll make an entry in our Route 53, and then our users are free to access the application from anywhere without a need of VPN, and we're making sure that we're getting right claims for device and identity and making that trustworthiness happen between the end user and the application. So that's pretty much from me. Thank you so much.
Right. Thank you, everyone. We've got some Q&A. As far as Q&A as well, if you open up the app, you can submit a question. Also, in the room, if you have a question, I can repeat it for the audience as well. But thank you both. Great content when it comes to two solutions for managing and securing Macs with AWS. We've got a couple questions, at least to start, one for each of you to start as we go. Probably for you, Dave, question about snapshots and testing. So can I create my own snapshot, so to speak, of an EC2 Mac? For testing, I'd like to be able to roll back to a good starting state after testing things.
That is a wonderful question, and the answer is yes. Those images that we were showing in the console are, for the most part, starting points. You're able to take a snapshot, and from there, your AMI can be used to launch any additional instances from. So that is not only can you do those snapshots for backup, they can instantly become the template for every other instance that you're launching. We do also have a feature relatively new called Replace Root Volume, or RRV, that can do that in a little bit more of a rapid-fire fashion. So if you needed to get your instance back to its original state, another snapshot, or just a different AMI, it's actually possible to do that without entirely stopping and starting a new instance.
Awesome. For you, Mayank, I've got a question that just to frame it, if someone, so the question says, why verified access? Why would it be better than Jamf Trust? But I think maybe to elaborate, like, what would you say the differences would be if someone was looking to use AWS verified access using Jamf as a trust partner versus, say, if they had Jamf Connect CTNA and Jamf Trust app? Both can have similar paths, but what would you say the differences would be for steering one way or another for secure access?
Yeah, that's a good question. But so if your applications are actually hosted in AWS and the verified access integrates very well with other AWS services, obviously, so it makes it very easy for you to actually make that connection and access to your applications. So we are still using Jamf Trust in the backend to get those claims to make sure the device and the user is actually trustworthy, and the device is not compromised in any way. But yeah, that's basically makes it easy for our users to gain access to their applications without a VPN.
Awesome.
Does that answer that question, though?
I hope it answers the question. I mean, truly, there's different paths to get. If you're looking at securing an endpoint, this is certainly a very focused one. If you're looking at AWS applications, it works very well. With that, how can people find you or connect after the session as they have more questions?
So we are actually at the booth downstairs, so you can feel free to swing by, and we'll be happy to have a chat with you guys. And you can also book a meeting with us. We have a link over there. We'll keep that link open for a week or so. So you're always welcome to book a meeting with us, and then we'll be happy to connect offline as well.
Yep, and we're absolutely resources that are experts on this sort of thing. So as if you engage with your AWS folks from within your organization regarding any of this, we're going to be happy to help out on this.
Awesome, thanks. Give a round of applause for Dave and Mayank. Thank you for attending.